Hi guys, welcome all of you on this 13th session of the AWS system admin training. And can anyone quickly confirm am I audible or not? So we can just go ahead. Perfect. Yeah. So let me quickly cover up what we have learned in the previous session. So in the previous session, I have talked about the storage thing, the partitions, what are the inode tables, and there we have the format types and the block devices. I have talked all of these about. Uh, but in the storage world, we have some challenges about the storage limit. So that thing I will teach you here in this session, and after it is done, we will go for the networking things and or I will start some server things so you can set up your own multiple type of server like your a TB server or your web server or your like NAS server. You have multiple type of server. So I will tell you how you can configure it, and slowly we are going into the configuration part also. So I have showed you the demo of the provisioning, what the means of provisioning. If you guys are seeing our previous video of the GitLab CI/CD with Terraform integration series, so there I have talked about the Terraform also for it. Like if you don't didn't watch till yet, you can go there and you can check it. There I talked about Terraform and yeah, how you can provision your resources from the Terraform. That's a tool like which you can also. I have showed you the Portal library, how you can use a Python code to provision the resources in the AWS. We have a multiple more things in the Boto, so that thing I will talk in some time, because for that we have to like learn some more things in the Python and in the programming language perspective. I will talk that thing later. But you can use Terraform and the AWS CLI and the Python Portal library for the provisioning of your AWS resources. And after it's provisioned, the next part is we have to configure it. Okay. So if I talk go on the previous session, like which I topic which I told you. So for that, what we have done there, we have attached a disk. So in the local we have attached the disk on the VM. So like the same way we can attach the EBS to EC2 also. So after that we have done the partition here, we formatted, we created a mount point, we mounted, and that same thing we can do here also, all the same thing. But if I talk about the mount, so you know what we have done. We have created, we have attached the disk. I can say the EPS volume, and after that, what we have done, we have created the partition or block from this, and after the block, we have formatted, and then we have mounted. So the thing is, if you go and mount to where mount point, So if you see this link which we have mount to mount point, this is temporary. What's the means of temporary? Is the thing is it will mount the disk, but if your system reboot, so the this mount is like unmount. You can say it will unmount the link which we have on the disk partition and the mount point. That link will be closed, or we can destroy, because the mount thing is not permanent. In the technical word, we call don't call it the permanent. We call it a persistent. So all the things if you have created a new file and save it, so all the things which you have stored in your storage, that called the persistent uh, data. That's why in the storage we called is uh, in the storage we called is persistent volume also. Uh, we called is persistent volume. So if you didn't know about the what is and the cube, if in the DevOps world we have a one tool called Kubernetes. We have similar tool called of OpenShift. There we use this term persistent volume. Also, they have a one resource type also with the same name, persistent volume. So that also which is give us the same kind of capability to store our data persistently. So if our system reboot, we have created the new VM, we can use our same data. So mm, the thing is, everything which is stay as it is when our system reboot, that we called as a persistent. So the mount is not present. For that we have a multiple way. The first way is you know we can run our mount command, I have showed you some kind of mount slash dev slash sdp something sdp1, and we are created the mount point. So we can use that. So what we can do, we can run this command at the boot time. So at, in internally what we are doing, we are running this command and every boot time. This is a one way. And second way we have uh, as like fstep, fs tab, yeah, fstep we have. So this is a one way to where we can where we can start our mounting thing automatically, so we don't have to do all the things manually. Once our system reboot, it will go there, it will mount. Also it can do multiple more things, so that thing I will talk later. But with this way again, so I am not giving the solution of this challenge, the persistent volume, the mount thing. But there was one more problem which comes with the storage. If you know, we are having using any storage. So every storage have some size. This is the thing which we have the one big problem. So what we have that in the current world, if you know, data is increasing exponentially. If you say we have another domain also related to the data, we have multiple domains related to it's if you call data engineering, data analytics, data analysis. So we have multiple kind of thing. But the main thing is if your data is increasing, so you have to store it somewhere. But if you have a limited size of storage, how you can store the unlimited data there? So what yeah, if you think about, there is nothing called the unlimited thing in the technical perspective. Nothing is unlimited. You have a size, that size of data you can store. The thing is, if you have a lot of bigger size of storage and you are storing a limited amount of data, so you will feel like we have a unlimited storage. But it's not like, if you guys have like, I can give you another example what unlimited means and in the technical purpose. So if you guys have your Wi-Fi plan, so generally what a mobile company says, uh, we are giving you unlimited data, but it's not unlimited. The thing is, the threshold, the capacity and the threshold, what they have said, it's like far away from your capacity. So, for example, uh, what the Wi-Fi company does, they give you almost a 3.3 TB data uh, in a month. So, if one person is using this data, it will feel like it's unlimited. But if you have a, for example, if you have a 1 Gbps speed, 1 Gbps speed, so you can think about 3.3 TB is around 3.5 K Gbps around. I'm not doing any mathematical calculation, but it's around 3.5 K. So in the 3.5 K second, like around 35, so you can consume your whole data in the 1 hour also. But the thing is, if you are choosing 1 Gbps of plan, they will not give you this much. If you are using 30 Mbps of plan, they will give you this threshold. So the thing is, if you try to see, if you are using 30 Mbps and trying to consume 3.3 TB, it's a lot of. It will take a lot of time. Like, you will take more than a month. So every month you will think like we are getting the unlimited kind of storage, but it's not. We have a limited, but the threshold and the data consuming speed is low as compared to the things what they are giving to you. Okay, so here you have in the storage world, we also have this issue of the storage capacity. So for that, uh, we have a multiple kind of, we have a dedicated tools and servers also, which called one of the tool is called Hadoop, if you know. This is the server which provide us SDFS. Uh, so it's like a Hadoop distributed storage, storage. So what they will give, uh, in the Hadoop cluster, what you can do, you can create a one master here, and here you can attach the node, multiple nodes, and the master duty is to manage all of the nodes, and the node duty is to provide their storage to the master. Okay, so we will connect on the master, like we are the clients, so we are connecting from the master to the nodes. So at the end, we are getting the storage from the nodes, but the thing is, if for example we have 100 gigs of storage in every node, and we have 4 nodes, so our master will think about, we they have 400 gigs of storage. And if you need more than 400, what you can do, you can launch a one more node and attach it, so you will get the 400 and 100 GB, you will get the 500 gigs of storage. So like this way we can use the HDFS, and this is the one like a more usable tool, like a most popular tool in the storage world, and this domain is called as the big data. So it's like in the big data world you will always see the we are using Hadoop for storing the data. So also we have other tools also, like we have a cluster FS. So multiple tools we have, but this is for the cluster storage cluster. And in our system we are not especially managing the storage cluster anyway, and we are getting the storage from there. In our system, if we have to face the issue of this limited storage, so how we can tackle it? We can attach the multiple disk. Simply we can attach the multiple disk, but there is one more issue. For example, if your every gigs like you are attaching 20 gigs of, so if you are using here, for example, you are using you are mounting it in dir1, dir2, and dir3, dir4. So each of the directory you can store 20 gigs of. But what happen if you want to store more than 30 gigs in one directory? So we can't do that. Just give me 1 minute. Yeah. So generally we can't do that thing. Hello. Hello. So generally we can't do that thing because in one partition we can't store more than that capacity data. So what we can do, if we are combining, for example, we have one more disk or 20 gigs. If we have some way, we can combine these two. So in this directory, we have a two disk or 20 plus 20 gigs, and it will give around 40 gigs. So that kind of thing we can do. And the thing is, we don't have this thing on the actual basis. We have it in the logical basis. So in the Linux, we have one tool called the LVM. It's a logical volume manager. So with the help of this tool, we can achieve this capability. Also, you can do the same thing by the EBS also. If you want in the AWS, you can do it. And but in the LVM, we don't attach the disk directly to the mount point. We have some way. What the thing is, L disk like the way we are creating the partition and format it. We don't use that way in the LVM. In the LVM, we start from the disk, and from the disk like the way we are creating the partition. Here we create the PV. PV means physical volume. It's not the persistent volume, it's the physical volume. And we use this way. Just what happened with this? Just give me 1 minute. I think something happened. Okay, no problem. So we will create the PV here first, and after the PV, what we are doing? Let's see if we have a disk one and disk two. So we can create the PV from there, and if we want to combine, we have to combine it on one group. And which group is this? Is the volume group. So we called is a VG. So we are attaching the PV to VG. So we have the VG, and from this VG, we can create the logical volume, and we can treat like this logical volume as our block device. Now we can format it and mount it. That's a simple. And you will think about, like, we can store it, but also we can get the one more capability here to resize storage on like, and at any point of time, like, for example, if you have 20 gigs of this, 20 gigs of this, you have around 40 gigs, you are creating 40 gigs. If you see you are getting the storage data, storing data frequently, and in some time this 40 gigs will be totally consumed, what you can do, you can use another disk of 20 gigs, and you can create the PV, you can attach it, and from that you can increase it. So it will become uh, 40 plus 20 is 60. It will become 60 GB, but you don't have to unmount, and you don't have to stop your process to storing the data there. So you can increase it also. And the thing is, like the same way, if you guys have used Google Drive, so Google Drive also using some kind of this. It's not the actual this method they are using LVM, but some kind of, you will see they will give you 15 gigs of thing, and they have subscription plan. So once this data is filled, and they will say you give around, I think, 125 rupees in a month. They will charge you, and they will give you 100 gigs of storage. So it will not like they create a one more block for you of 100 gigs. They will go on your actual drive, they will copy all the 15 gigs data here. It's not like what they are doing. Once you buy their plan, so what they are doing, you are using right now the check, create. Okay, yeah. Sorry for this disturbance. There was some electricity issue. Uh, so where I am, what they are, mm, they don't increase the size like this. What they are provided the 15 gigs as a free from their logical volume, and once you buy their subscription, they are increasing this to the 100 gigs. So it's like once you buy the subscription, you will see your storage size is quickly extended to the 100 gigs, and you are not losing your data. But the thing is, if you are trying to copy 100 gigs, sorry, 15 gigs to anywhere else, it will take at least around 10-15 seconds if you have a like lot of a bigger IOP also, but it will take. And what happened, like, after the 100 gigs, you are buying one more subscription and you are switching to the 200. So at that time it will take more time. But for the Google, if they uh, give you some downtime or some kind of it will take some minutes also to do this stuff. It's like they have to they don't want to wait their client, which is us. So for that, they are using this way. This kind of exactly they are not using LLM, but you can use the same approach and you can create your own tool if you are good at programming and that stuff. If you know, so you can also use this concept. And I have used some kind of thing. This integration, uh, some kind of this integration with the SDFS, and I use LVM integration, and we have one more coin, the swap thing. So I integrated these all three, and we can give extended swap memory, like infinite or unlimited swap memory. You can give any system. So I have done this kind of things. So you can also think a little bit in deep, and you can do perform the same action there. Uh, Also, the thing is, if we are we can increase increase it uh, on the mountain, but for the decreasing it we can't do on the online mode. It's called like online mode. Like our mount point is connected to the mount point, we can't do that. For that, if we have to unmount that, then we can reduce. But if we want to reduce some logical volume data, so we can also reduce that here. uh, how we can do, which command we are using, that thing, the practical thing we will talk in the next session. And also I will tell you like how you can use the S tab, uh, and we have multiple things in the S tab. Also you can also use your storage to manage your RAM. So that concept is called as swap. I will talk this thing later on. But in the PV and this logical volume manager, if you have any queries, you can ping us right now. And otherwise, I will like go and start little bit other topic uh, which we are using here in this training. So if you have, I can wait for 2 minutes and then we can go ahead. Okay. So if you remember, we have installed, we have set up the Yum repository, and we have installed some package in the Linux world. Uh, if we don't have the Yum, so without the Yum, we have other way also for installing the packages. What ways we have? What happened? Yeah. we can install the package uh, in other ways also. Uh, it's like we have a other package manager also, and one of the package manager called the Red Hat package manager. I think Red Hat, Red Hat package manager. Manager. We called is a RPM. So with the RPM also we can install the thing, and we can check if any package installed here or not. So I can show you the quickly the demo of the RPM and what kind of things you can do with the RPM. You can like installation. The thing is, if you have set up the yum repository or repo here, so you can use that. But if you have any kind of binary file and you want to just install from that, for that you can use the RPM. And how you can, so you have a RPM. I am just writing, so you can see RPM is copyright Red Hat, so it's Red Hat package manager, and they will give you a complete flags like what are the parameters out there, and you can see RPM hyphen a, or you can use hyphen all, both ways. And if you see whatever, or let me just say man, RPM, yeah, RPM package manager, and this we can query that, like is any software is present here or not. You can verify install option, we can use for the installation also. And we have a lot of things like for the installation you can use a hyphen I. So if you know, for example, I am using Q Python 3, so it's in this. I don't know Python is not installed. Yeah, if you see this is installed, I think I am giving something now wrong. So if you have this, if you can see this Firefox, and we have this version of Firefox in the system, and if you see all the files which is created by the Firefox, you can see here. So they will, you can also list the files which is created by the Firefox. So if any package you installed and you have done something configuration, you are installing that, and that will not remove all the files there. So you can check with this way what are the files are affected with that package, and you can just check it. Also you can use hyphen a, or hyphen a will give you all the list. It's like completely big list they will give. So you can use this thing also. I think we have a one more hyphen info, I think. So we have an info thing also. So for every package, we can check the information of that package, like what's the name, which version we are using, uh, which releases, which architecture is the installation date, when it is all the size and the license signature. You can see everything, and if you can also see the packager, which packager they are using, and the URL from there itself. So that kind of thing you can see. Also, it's not about the Firefox. We have a date also. So no date. We don't have a date package. We have other packages also. You can check that info also. With this, if you want to troubleshoot anything, you want to like many times itself for troubleshooting things and the what I say. Yeah, many times it's happened like what is the thing is that happen in our system. This file affected from sometimes it's happened like a one file overwriting by the other software. So that thing you can take care. Also, if you have a manager, you can use RPM hyphen I V is for workloads. H will give you hash format. And if you are not familiar, you can just go here. It will show here RPM I am using I. So H you will see hash format, and I is for install, V is for the verbose. So it will give you the verbose kind of thing. So you can use this thing, and then you can give your binary name for installing any package. Also, with the RPM, we can do multiple other things, like you can also see the source code from where it's coming. So that kind of thing you also can perform with the RPM. If you want to see the repo where is the actual source code is happening, so you can just use these flags, and you can start it. Yeah. So if you want to see if which package is created this one, so this will give you the file, all the file name. If you want to see, for example, if you know we have a date command, and if you want to see the path of that, you can use which command. It will give you this. And if you want to see the things like from which software it's coming up, so you can use RPM hyphen Q. And if you go on the top, we have a one keyword called the file. So we can give the file name usr bin date. So you will see from which software it's coming. So you can see all the things like from which software it's coming, and you can check. Okay. And there's one more thing that I can show you. I am not right now getting the exact command what we are using for checking the source code, but I'm sure you can use the same things. You can use the same RPM command for checking that also. They have some way, for example, RPM FNQ. Yeah, you can see this is the URL of the software. If you want, you will open. I can't open right now because of the issue happened, and then the network setting is changed, like the previous thing which we have faced. So you can go on this link and you will see the so one kind of repo, and then you will see the actual code. So I can show you the code of code. So with this repo, it's coming the manual thing. So and I think this one. See, these all the scripts, and if I can show you the date command. So this is the actual code in the C language, which you can find in like which we can use to find the and this command is executing at that time. So like this way you can check what's the source code. If you want to contribute here in the open source also, you can use this method. Okay, so like this way you can use the package manager, and you can install the package. And uh, the practical thing of LVM and resizing the storage, I will talk this thing from on the tomorrow session. I'm going a little bit fast, right? Like now, because in the initial session we are going so slow, and I am explaining each and every concept in very basic, because we are not familiar with them and cover the multiple topics on one go. If you have any queries till yet, you can ping on our group and our other handles. We will try to help you as better way as we can. And till the time, practice this all concept. If you like this video, uh, share with your friends, like it, subscribe to our channel, and